In this lesson, we'll be learning about congruent figures. The objective is to recognize congruent figures and their corresponding parts. First definition is congruent polygons. Congruent polygons have congruent corresponding parts, which means their matching sides and angles are all congruent. So when you have congruent polygons and you name them, you must list the corresponding vertices in the same order when you name them. So in this example, we have polygon ABCD is congruent to polygon EFGH. So the way you name the first figure determines how you name the second figure, because the second figure has to be named in the same order of corresponding vertices that you named the first one. So in this particular example, we have angle A is congruent to angle E. So you can tell this just by looking at the name. Look at the corresponding positions of the vertices in the names of the polygons. A and E are in corresponding positions, and they're in corresponding position in the polygons. So A is congruent to E, and then you have B. B is congruent to angle F. And then next you have angle C is congruent to angle G. Forgot my angle marking on F. And then finally you have angle D is congruent to angle H. Those are the angles that are corresponding and congruent. You also have corresponding sides, which are going to be segments. So we have segment AB is congruent to segment EF. And once again, you can see in the name the AB and the EF correspond to the positions in the name as well. And you have side BC, segment BC. BC is congruent to FG. And then CD, side CD is congruent to GH. And then the last one we have is side AD is congruent to side EH. The triangle sum theorem is a theorem from a previous chapter that we need to review in order to understand congruent figures. The triangle sum theorem says that the sum of the measures of the angles in a triangle is 180 degrees. So if we just draw a picture of a triangle here to illustrate this, we have triangle ABC. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180. So that leads us to the third angles theorem. And the third angles theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So in this particular example, we have if angle A is congruent to angle D, and angle B is congruent to angle E. Notice the congruence markings in the diagrams indicate that those angles are congruent. Then you can state that angle C is congruent to angle F. So let's use these in the problems on the right. In problem 1, you are asked to find congruent parts. So it states if polygon RSTU is congruent to WXYZ, then what are the congruent corresponding parts? So you don't even have to have a diagram. You just go by the order of the letters in the name of the polygon, and you can match them up and get the matching corresponding parts. So let's look at the angles first. If we look at the angles, one of the angles of the polygon is angle R, and that one corresponds to angle W because they're both in the first positions of the names of the polygon. The angle S is in the second position of the first polygon, and then angle X is what it's congruent to in the second one. So angle T has to be congruent to angle Y, and angle U has to be congruent to angle Z. So those are the congruent corresponding angles. We also have 4 congruent corresponding sides that are going to be segments. So once again, going by the name only, if you look at side RS, RS has to be congruent to WX, and side ST is congruent to side XY. Side TU is congruent to YZ, and then side RU is congruent to WZ. In problem 2, we're using congruent parts. It says the sides of a roof suggest congruent triangles. What is the measure of angle 1? So looking at the diagram, it already has sides that are marked congruent, and it has 2 angles that are marked congruent that are right angles. It has a 48-degree angle in the triangle on the left. So since it says it suggests congruent triangles, that means that the corresponding angle in the other triangle also has to be 48. And the measure of angle 1, which is the angle that we're asked to find, is going to be congruent to the measure in the triangle on the left that matches it, the matching corresponding angle. So if we look at this, how do we set this up to find the measure of angle 1? So the measure of angle 1, since we know from the triangle sum theorem that the sum of the interior angles of any triangle is 180 degrees, so that means that the measure of angle 1 plus 48 plus the 90-degree angle, which is the right angle, has to be 180 degrees total. So that's, let's combine like terms. Measure angle 1 plus 138 is equal to 180. So the measure of angle 1 if you subtract 138 from both sides, it's going to be 42. Problem 3, it asks, are the triangles congruent, and to justify your answer. So justifying your answer typically means we're going to use properties and theorems that we've learned. So let's just make the statements here and justify them as we go. So we're going to look at the triangles and see what they've given us. We're going to say that the triangles are congruent. So yes, triangle ACB is congruent to triangle ACD because We'll start listing the reasons why here. We have AC, segment AC. That's a side of both triangles. It's shared. Anytime you get a shared side, you can use the reflexive property to say that AC is congruent to itself because of the reflexive property of congruence. And we also know that angle ACD, these two angles down here, are congruent because all right angles are congruent. So we have angle ACD is congruent to angle ACB because all right angles are congruent. That's a right angle congruence theorem. And we also know that the angles up top, we have angle BAC congruent to angle DAC because of the third angle theorem, which says if two corresponding angles of two triangles are congruent, then the third angles are congruent. So the triangles are congruent by the definition of congruent triangles. In the last problem, we're asked to prove that these two triangles are congruent. We're asked to prove that triangle RST is congruent to triangle RUT. So let's do a two-column proof on this one. Let's put the statements on the left side and the reasons on the right. So the first thing we're going to list is the information that we're given. So in statement 1, we're given that segment RS is congruent to segment RU, and we can put all this in the same statement. Segment TS is congruent to segment TU. Angle S is congruent to angle U, and angle SRT is congruent to angle URT. So all of that information is given to us. It's listed in the diagram and it's listed in the given information that we're for the proof. So the next thing we need to look at the diagram and see if we can determine if anything else is congruent that we need. Once again, we have a shared side. RT is a shared side between the two. So that means that it's congruent to itself. So in statement 2, we're going to say that RT is congruent to itself. That gets us the third side to be congruent that we need. So the statement that's reflexive is the reason. Reflexive property of congruence. The next statement that we can make by looking at the diagram is that the third angles, we have two angles that are congruent at S and U. We have a second angle that's another pair of angles that are congruent at SRT and URT. So now we can state that these third angles, which are angle STR, so STR is congruent to UTR by the third angle theorem. Because if two angles of two triangles are congruent, then the third angles are congruent. So now we have all three sets of sides congruent, corresponding sides are congruent, and all three sets of corresponding angles are congruent. So we can make the statement that we're trying to prove that triangle RST is congruent to triangle RUT by the definition of congruent triangles.